Acha, electricity starts off from the fact that we have an electric field, let's say. An electric field is a region of space where a charged particle will experience a force, right? Our test charge is a positive charge. Right? Initially, all the experiments were done keeping in mind that charges are positive, right? One of the reason why in physics we have a conventional current flowing from the positive into the negative terminal. ठीक है? अच्छा, electric field is of two types. We have a uniform electric field, right? And we have a non-uniform electric field. ठीक है? Uniform electric field, every point experiences the same force, right? A non-uniform electric field, force will vary. Now you need to understand that uniform electric field is usually obtained. Let's say I have plates. Please understand the fact that electric field lines will move from the positive towards the negative plate, right? One more thing that you need to note is that these lines are equidistant apart. So, whereas the non-uniform electric field is found in charged particles. If it's a positive charged particle, field lines move out from the charged particle whereas if it's a negative charged particle, field lines will move into right. This is established from the fact that if I were to take a positive test charge and place it somewhere in the field here, this positive charge would repel and push it away. Thereby, we establish the fact that field lines are moving out of the positive charges. We use a symbol, we use a quantity called the electric field strength. Electric field strength is defined as the force per unit charge. Right? Or you could say force in an electric field. For uniform electric field specifically, your field can further be broken down. Let's say positive and negative has a potential difference. The distance between the plates is a value called D. So the electric field strength can be further broken down as E is equals to V upon D. This is specifically for uniform electric field only. Next, you need to understand what exactly is current. Current is the rate of flow of charge. Right? Or in simple terms, you could say current, which has the symbol I. Charge has the symbol Q. Or you could say right, where time is in seconds, time is measured in seconds, current is measured in amperes. And charge is measured in coulombs. Right? If I were to give you a question saying, a current of 2 ampere flows in a time of 5 seconds, calculate how much charge flows through a point during this time. You're going to simply use the formula Q is equals to IT. You're going to apply 2 ampere multiplied by 5 seconds. That would give you 10 coulombs. Straightforward, right? But if I were to ask you another part saying, if each electron has a charge of 1.6 into 10 to the power of minus 19 coulomb, calculate the number of electrons that will flow through a point during this time. It says that each electron has a charge of this value. One electron has a charge of 1.6 into 10 to the power of minus 19 coulombs, right? Calculate the number of electrons that will flow through a point during this time. You had a charge of 10 coulombs. So if I were to work out for 10 coulombs of charge, don't you think cross multiplying this value would approximately come out to be, I think, 6.25 into 10 to the power of 19 electrons. Voltage. Voltage is basically defined as voltage is defined as work done or kinetic energy. Work done can be equated to different forms of energy. Work done per unit charge. If I were to, let's say, break it down into symbols, I could say voltage has a symbol V, work done has the symbol, let's say, W, and charge has the symbol Q. Right? Let's say for a minute. Right. Moving forward, by the way, voltage is measured in units of volts, right? Charge again, coulombs. Work done in joules, right? This has a short of form of capital V. Now, let's say if I were to talk about power, you know for a fact that power is equals to work done upon time, right? So P is equals to W upon T. Work done can be substituted as VQ, right? So simply just substitute VQ upon T. You need to understand that Q upon T is a quantity known as current. So I'm simply substituting that value and I will realize that power is equals to IV or V upon I. Similarly, if you had to work off for energy, right? Energy energy is equals to power into time. Power can be broken down into IV. So energy is equals to IVT. Right?
So एक particle की energy निकालनी है.
Let's say I have a circuit where the battery involves this pole and this pole, right? And the battery is rated at 12 volts. Now you need to understand that for every battery, there is a certain internal resistance that it needs to fight off or work against in order for the current to flow out, right? So if I were to ask you to calculate the current here, you're going to apply the formula V is equals to IR, right? By the way, this formula is for ohmic conductors. We're going to move on to that, right? Your voltage value is 12 volts. Your current becomes I. Your resistances will add off 2 ohms plus 10 ohms, and that would give you 12 ohms of resistance, and you'll realize that your current is 1 ampere here. right? Now, if I were to ask you to calculate the voltage dropped here, you're going to apply V is equals to IR. A current of 1 ampere flows through the entire circuit and again reaches here. Whenever it enters the resistor, there is a potential drop calculated from V is equals to IR, right? There's a resistance of 10 ohms. The current is 1 ampere. You're going to work out that 10 volts are being dropped here. And when there are 12 volts in the entire circuit and 10 volts are being dropped here, definitely 2 volts are dropped across the internal resistance. Now you need to understand one thing, that the internal resistance will consume these 12 volts in order for the circuit to start working. And therefore, this voltage that is dropped is termed as loss volts, right? And the external circuit, this thing could be anything, like any load that you could actually see around you. Could be a bulb, could be a fridge, could be any single thing. Fridge will not have such a small resistance, by the way, but just a general perception, right? So the external circuit where the voltage is dropped is termed as terminal potential difference. Now you need to understand one thing, that the EMF, that is the actual voltage value, was this thing. The EMF is equals to the loss volts, which was in the internal resistance, plus the terminal potential difference, which will account to this value. Please understand that this value 12 volts, or as a matter of any value, would be the that specific value that is mentioned on the top of a cell. However, when starting to work off, there will be some drop in the voltage value. Next comes in conductors. There are different types of conductors, right? There is an ohmic conductor. There is a non-ohmic conductor. Okay. Ohmic conductor, V voltage is directly proportional to the current applied, will follow the relationship V is directly proportional to I, and therefore if you were to plot a graph of V against I, that would be a straight line through the origin. However, for non-ohmic conductors, the relationship is not valid. This relationship is valid for ohmic conductors. Ohmic conductors examples could be resistor, right? Non-ohmic conductors could be of two types. One is when the temperature increases, the resistance increases, as in case of a filament lamp. These objects will have a V is equals to I graph, such that it's a curve. You need to understand that the gradient of a V against I graph is your resistance. And since the gradient or the tangent is increasing at every different point, therefore the resistance is increasing. The other type is when the temperature increases, the resistance decreases. For example, a thermistor. Thermistors look somewhat like this, by the way. Filament lamp looks like this. So they will have a graph of V against I. Somewhat like this. If you check the tangent, tangent keeps on decreasing, and therefore the resistance decreases. Next comes in types of circuits. There is a series circuit. There is a parallel circuit. Let's say, for example, I have now in a series circuit, your resistances will add off. So the total resistance can be calculated by adding off the individual resistances, and that will give you a value of 12 ohms. If you were to apply V is equals to IR and calculate the current, you have the voltage value. Your current value can work out to be somewhat like 1 ampere, right? In parallel circuitry, your resistances divide off, right? Such that 1 upon 4 plus 1 upon 8 gives you 1 upon RT. And I think that comes out to be somewhat, if you may have a calculator, please check. Whatever the value comes out to be, that is for 1 upon RT. I think approximately 3 upon 8. You will reciprocate the value. And I think this will be 2.67 something, right? If you were to apply V is equals to IR here, right? Your voltage value is 12 again, right? Your current value could work out to be, I think,
I is 4.5.
4.5 ampere. Right. By the way, please understand that once I've applied this formula on these two resistances, they can be considered as one specific unit of resistance. For a series circuit, right, your current stays the same, your voltage divides. Right? You have the formula V is equals to IR. So when your current is constant, your voltage divides such that it is directly proportional to the resistance. For parallel circuit, your current divides, your voltage drop is constant, when you have V is equals to IR and your voltage is constant, so I is such that resistance goes to the other side. It is inversely proportional to the resistance, right? So if I were to introduce, if I were to check off this circuit, please understand that if I were to check on the value of voltage being dropped here, voltage drop is equals to value of the resistor, which is 4 ohm, divided by the total resistance, which is 12, 8 plus 4 is 12, into the EMF value, which is 12. And from here, I can work out that the voltage dropped is 4 volts here, and therefore 8 volts is being dropped here. So the greater the resistance, the more is the voltage being dropped, right?
So ये वापस बताएगा ये 4/12 किस चीज का था?
Here I have the formula. Voltage drop is equals to resistor in consideration upon total resistance into the EMF or the cell value.
अच्छा ठीक.
Right, this is merely a ratio and something that we have made it for ourselves.